All right, let's say you are asked to take some data and turn it into a probability distribution. Remember that the probabilities are just simply the number divided by the total. So in this case, and I don't know, I mean, I'm going to open this in Excel just to show it. You probably don't need to, but it just makes it a little bit faster and easier. Is the first thing that I need to know is the total number of employees. So I am going to use an Excel formula because I am lazy to sum those. You could have just simply put them in your calculator and added them all up. So I see there's 195 of them. So now for each probability, so this is going to be this column. Oops. And again, I'll do it in here in Excel, but there's really no need to use Excel. What you're doing is you're taking each number of employee in each category and dividing it by the total. So again, me being lazy, I'm going to use Excel because I can copy this formula. So the first one, even if you used your calculator, I use an equal sign in Excel. The number of employees in this category with no overtime hours divided by 195. Now, if I put dollar signs here, and I can do it very quickly with pressing the F4 button, what this is going to do is when I copy this formula straight down, it will always put 195 on the bottom, but the 7 will actually move. So I hit enter. And so I get that first value here, but because I'm lazy, I'm going to actually copy this formula, and you can either copy it and paste it straight down, or a quick way in Excel, you can grab this corner and drag it straight down. Okay. Again, you know, all of this can be done by hand. It's just, I'm lazy. And so now each one of these values, I can type in here and it says round to 3 decimal places. Well, I can be really lazy and go here. What is that? 1, 2, 3 decimal places. And now I can simply type these values in. So this is gonna go away. So I'll have to kind of jump back and forth. 0.036, and then it was 0.067, 0.067. And then 0.128, 0.128, and I think I remembered that one was 303, yep, and then 0.226, and then 0.149, 0.149, and I think that is correct, 0.092. So all you're doing to construct a probability distribution is taking the number in that category divided by the total. So I check my answer and it says, oh, I did a good job. So again, you could have taken your calculator, 7 divided by 195, 13 divided by 195, and so on. And now the graph, what it's graphing, the probabilities is the height. Okay, so I can kind of see that, you know, by looking at this, I know it's not this part C. And you're like, well, how do you know that? Because this is going down, right? So it's actually a lower probability. I also don't feel like it's part B because look how high this one is. This should be at 0.03. So my choices are A and D. So what I'm looking for, and I can zoom this in a little bit, is this first one being like 0.03, this one 0.06, this one 0.128, this 0.303. Then it goes down. So notice that it goes down to 0.226. This one right here looks like it jumps way down. So I feel like it is this graph right here. Now, if you did this in Excel, for those that are savvy with Excel, watch what I could actually do. I could highlight these. I could go to Insert. I could look, oh, not the histogram. I could look at the values right here. And besides there being space there, I can look and see which graph this matches. And once again, it was this big jump down right there that I could see it doesn't match. So I click check answer and woohoo, I did a good job. It says describe the distribution shape. Now, uniform means they all have the same probabilities. Okay, so it's definitely not uniform. Skewed to the right would mean that the data, the majority of the data is to the left. In fact, let me show you something real quick. So skewed, I'm typing this where you can't see it yet. Skewed to the right, to the left. I just grabbed, a graph real quick. Notice this here, okay? Like where it talks about, let me do this one since it uses left and right. Left skewed means that the majority of the data is to the right. Most students get those confused. Right skewed means the majority of the data is to the left because it kind of skews as it goes to the right. Approximately symmetric is the bell-shaped, okay? So this doesn't really look, massively. It looks like it could be left skewed, right? So the majority of the data is to the right. So let's check that. It says that's incorrect because I think that it's thinking that it is pretty much symmetric bell-shaped. So you have to be careful with these. Let me go back and show you right here. Here is the bell-shaped curve. So being skewed would probably be more of the data is like the more of the data is here to the right. So this is kind of bell-shaped. So you have to be careful when you look at these to get the actual skewness of it.